Hi, folks. Today's topic is three-dimensional graphing. So the tough part of this is we're going to try to sketch a three-dimensional picture on a two-dimensional surface. Now, our TV does this, right? Our TV is a two-dimensional surface, and the way the light, the perspective, you can infer what the picture looks like. So it looks like a 3D picture, but it's on a 2D surface. So I'm going to start by talking about a couple different things. There's these things called octants, and then the actual points themselves are instead of just X and Y, there's an X, Y, and Z axis. Now, it might be, maybe you can just look at this and you see it already. There's 8 octants instead of just 4 quadrants. We used to have just, X and Y, there was 4 quadrants. Well, in 3 dimensions, there are 8 octants. And I think it's easiest to see this with this 3-dimensional space. So this is what you're looking at. This is what I'm talking about when I'm looking at octants. Now, our paper looks something like this. So if I go back and I talk about one of these, let me zoom in. So this is in this class, now each course will have its own set of rules, but in this class, wherever the letter is, that's considered the positive part of that axis. So this is the positive X, and back here is the negative X. This is the positive Y, back here is the negative Y, positive Z, then down here is the negative Z. Now you should be picturing these axes as actually kind of coming out of the paper at us. So those axes are this part here. Now we can't, if I had them coming out of the paper, it looked like this, and you couldn't see the negative and the negative X and the negative Y axes. So that's why we got to kind of angle it down like this so that you can see the sections, or sorry, all the axes. These are what we call octants. This space here is called octant 1. And then it counts around just like we count around on the regular coordinate plane. This is considered octant 1. I think of this as kind of like a house. Okay, this is the top floor of the house. This is the bottom floor of the house. This bedroom right here is called octant 1. Then this over here is called octant 2. Back there is called octant 3. Then this is octant 4. And then the octants count the same way on the bottom, except they just go from 4. So 4, this is octant 5. Back here is octant 6. Back there is octant 7, really hard to see with the way this is graphed. And then this is octant 8 over here. Now a point in the coordinate in a 3D coordinate system has an X, a Y, and a Z axis. And the other page does a better job of showing that. Okay. Boy, excuse me. So here's our axes again. You've got octant 1 in the front, octant 2 on top of this, octant 3 on top, octant 4 on top, then octant 5 underneath this section. Underneath this quadrant, I guess you could think of it as. Underneath that quadrant is octant 6. Underneath this quadrant is octant 7. Underneath this quadrant is octant 8. Now here's the tough part. It's tough to decide where is that point. I mean, if you don't show how you got to that place, you can't really tell where that graph is. I'm trying to, boy, let me see if I can get it back. Yeah, that's what our paper kind of looks like. That's why when you graph a three-dimensional point, you got to make sure that you show the path that it took to get there. See, now it's unique. Now we can picture that there's this sort of rectangular, you can kind of make a rectangular solid out of that space that shows you where that location is. So if I go back, this is how we're going to graph it on the paper in a minute. Let me get it back to that's decent at least. So this is what you're going to look like on the paper. So I'm going to graph a point like, so here we are at the origin. Let's say I'm going to go backwards on the X 3 units. I'm going to go positive on the Y. So you see how the X-axis, we went backwards on the X. Then we're going to go along the positive Y. Well, that's going to take us from here along that parallel in that direction. I'll go, let's say, 5 units out or 6. And then from here, it's up or down. If I go up, my Z's go, if I go to positive 5, or if I go to negative 5, it's going to be from the same location. It's just going to go downward. And then you can sketch that rectangle if you want, or if you can see that path, you're good to go. So like, for instance, what octant is this in right now? This would be considered I can't quite get darn thing to, I don't want this to, I need it to straighten. There's straight. Okay, now I need to rotate. I don't want you to rotate. Is there like just a reset? Doesn't look like it. How about if I hit refresh the whole thing? There we go. Okay, so still not perfect, but we get the idea, whatever. Okay, so here's our point. We're going to add a point. I'm going to show the path. So right now I'm not in an octant. I'm just on the positive x-axis. Right now I'm not in an octant. I'm on the x. You can't really call this. This is the xy plane is what you'd call this. Combination of the x and y axes. And now I can put myself in an octant. Let me go a little bit farther on the y. So right now we're in octant 1. If I had changed that z to a negative number, we'd be in octant 5. 1, 2, 3, 4, 5, 6, 7, 8. Let's practice another octant. Let's go over here. Now what octant are you in? That's octant 6. I'm going to make these all 0. Let's see if you can figure out what octant you're going to be in. Okay, count your octant. You should have said 4. 1, 2, 3, 4. And this again, let me show you. If I take away that path, let's say that we're right here. If I take away the path, it looks like the point is way back there, but it's not. It's actually a little bit closer than where we are. This is octant 1, 2, 3, 4. And if I had dropped below that, that would be octant 1, 2, 3, 4, 5, 6, 7, 8. So you can add 4 to whatever your top octant is to get your lower octant. So let's try a couple. All right, so our first point we're going to try to sketch is -2, -3, and 3. And then we're going to identify what octant that lives in. So remember, here's your x-axis, and then wherever the letters are, that's considered the positive. So we have a -2, so I'm going to scribble back 2 units along the x-axis. So you see how I'm highlighting where I'm going? If you just draw the point randomly, you're not going to get any point. I'm not going to give you any credit because you have to show how you got there. Then along the y, so the y negative, I need a negative y. That's going to go back along this. So from here, I'm going to go parallel to that back 3 units. Squiggle again, 1, 2, 3. And then from there, I'm going to go up 3 units. 1, 2, 3, 1, 2, 3. And then I'm going to finally put my point. I'm going to highlight that. That's the actual dot. That's the actual point that we get to. Now, like I said, some people prefer to draw a rectangle here to visualize it a little bit better. So with the rectangle, you take this and you take the base and make it into a rectangle. And then from each ends, you go up however many units you went up. So this would go up 1, 2, 3, 1, 2, 3, 1, 2, 3, all 4 corners, all 4 vertices of our rectangle. And then you can play connect the dots. Now, I don't do this after this one. This is the only one that I just show this. So those of you who like to draw this, if this helps you see what octant it is easier, then go for it. But you don't have to draw that if you don't want to. Okay, so what octant are we in? See if you can figure out on your own. You got a kind of perspective look at it. All right, let's see what you should have gotten 3. That's an octant 3. Now I have a manipulative in class here. It's kind of tough to see, but I've got this thing that you can use that will help you figure out where the octants are. So you can use this to kind of help you count around on the test or on the quizzes. You don't have, if you're really struggling with the octant thing, I don't want that to be the only thing that holds you up. Okay, let's try another one. Let's have, well, we'll do a couple together. So this point is the point -1, 3, -4. So if you feel pretty confident, you can pause here and try to go ahead. If not, you can watch again. So this is my x. I'm going to start at the origin, and I'm going to go back -1. Notice how I scribbled so I can see the path. Then I need to go +3 on the y. 1, 2, 3. That's going to take me to here. Sometimes I draw it, and then I go back and highlight it again. and then -4. 1, 2, 3, -4. This is the actual point. All right, count your octants now. 4, 5. That's octant 6. That's a V and an I. Try to sketch the point 2, 2, -3, and then identify its octant. So 2, 2, -3. So here's a perfect example of why we have to draw the path. Because if you don't draw the path here, you can't see that that point actually isn't on the z-axis. It looks like it is, but it's out in front of the z-axis. If you don't draw the path, it looks like it's just we went straight down 6. You didn't. You came out, and down. All right, octant 1, 2, 3, 4, 5. This would be octant 5. Our next point we're going to try -2, 5, and 2. Like I said, pause if you feel like you're pretty good at this. Actually, I'll go through. I'll put all 3 of these up here, and then you guys can pause and try them all. 2, -1, -4, and 2, 0, 5. Pause it if you feel like you can go for it. If not, let's talk. So let's see. You went back 2, forward 5, 1, 2, 3, 4, 5. Then up 2, 1, 2. That would be octant 1. That would be octant 2. Forward 2 on the X, back 1 on the Y, down 4 on the Z. That would be there. One, 2, 3, 4, 5, 6, 7. That would be octant 8. And then 2, 0, 5, 2, 0. Ooh, this is going to be an interesting one. Then 5 on 1, 2, 3, 4, 5. So this is not an octant. This is what we would call the X. So this doesn't go anywhere in the Y direction. So this is stuck exactly on the X-axis and on the Z-axis. So we would call this the XZ plane. You could just call it the XZ plane. You don't have to say like quadrant 1 of the XZ plane. If you want to try to get fancy, that would be quadrant 1 of the XZ plane, but then this would be quadrant 2, 3, and 4. You got to be a little bit careful because your perspective is a little bit off. Okay, down here, we're reversing things. We are now given a picture in the path of a point, and you have to identify its coordinates and its octant. So let's see. So looks like I went backwards 2 on the X, so that's -2. Looks like I went forward 2 on the Y, so that's +2, and then I went 1, 2, 3, -4. So there's the coordinate triple. And what octant 1, 2, 3, 4, 5, 6. This would be octant 6. Have you tried one? See how you did. So I went forward 1, 2, 3, 4 on the X, 4, comma. I went backwards 1, 2, 3 on the Y, that's -3, and I went up 2. 1, 2, 3, this would be octant 4, which is I, and then the V. Last but not least, I haven't done a purple yet. How about a nice purple? 1, 2, backwards 3. 1, 2, 3, 4, 5, backwards 6. 1, 2, 3, 4, down 4. -3, -6, -4, 1, 2, 3, 4, 5, 6. I got that as octant 7. So like I said, you have a manipulative that you can use in class if you need it. But if you can just see it, I don't know how to teach you to see it. That's the tough part. You got to kind of envision it. And some people struggle with being able to picture things in their head. So the back is just kind of applying some of these ideas, and then we're going to do some formulas that we would normally do in the coordinate plane, but apply it to the two-dimensional coordinate plane. We're going to apply it to the three-dimensional coordinate plane. So identify the octant given the following conditions. So you are in a spot where x is positive, y is negative, and z is positive. So what octant would that be? So I'm going to kind of flip back here to this one. I like this one the best, so I'm going to turn this point off. Okay, so I am in an octant. I'm going to kind of just read what was on the paper. I'm where x is positive, whoosh, x is positive this way. Y is negative, so I'm back here, but z is positive, so I'm up here. So that would be octant 1, 2, 3. This would be octant 4. Next up is y is less than 0. That's all we know. So we're going to try to figure out all the octants that have a y that's negative. So if I go y negative, that's back here. So that would be all these octants in the back. So let's see what that's 1, 2, octants 3 and 4, and then underneath 5, 6, 7, and 8. So you can list more than one octant depending on how much information they give you. So octant, I guess I should say octants. I don't like saying octants. I'm going to just say octant. Octants 1, 2, 3, 4, 5, 6, 7, and 8. All right, you give it a try. On the next two, if you need to look at this picture, I'll hold this up there so you can hit pause and give it a try. All right, let's see how we did. So it would be, I'm going to read it from the paper. Negative x, back here. Positive y, up here. Negative z, down there. So that's octant 1, 2, 3, 4, 5, octant 6. I always get 4 and 6 mixed up. So that's why that 6 looks like a crappy Roman numeral 6. And then octant, ooh, this is interesting. X times y is less than 0. So that has to be an octant where x and y have what kind of signs? What kind of signs would you need to be opposite of each other? Obviously, they'd have to be opposite of each other. Sorry, what kind of signs would you need to have to multiply to make a negative? They'd have to have opposite signs. So this is where x is negative and y is positive and vice versa. So x is positive, y is negative in these two octants. So those are two of them. X is negative and y is positive in these two octants. So if I were counting around, I would be octant 2, 3, 4, 5, 6, 7, and 8. So octants 2, 4, 6, and 8. And then we've got a couple of formulas. You want to put these on your unit circle, feel free. You do not need to memorize them. And I think this whole lesson is just kind of a fun, something that you've never seen before, kind of a lesson. So if you want to put these on your unit circle, feel free. So find the distance between. So we have a distance formula. Remember the distance formula in 2 dimensions looks something like that, right? Only has x's and y's. So we're just adding that z component. So distance equals 4 minus a negative 1, which would really be a positive, plus 1 minus a negative 4, which would really be a positive. Then negative 4 minus 3. Oh, I didn't really go, sorry. I should zoom in. Now we can clean this up. So that's what? 5, that's 25, that's 50. 50 plus 7, 49, 50, 99. Get your calc, double check. Why is this an unacceptable pre-calculus answer? Because you should be able to clean this up. So I'm going to encourage you to pause and try to clean this up on your own. Try to find the biggest perfect square that goes into 99, and that's 9. 9 escapes, becomes a 3. The 11 is left in the root. And then last but not least, find the midpoint. So we have this midpoint formula, if you remember from geometry, the midpoint formula. So think about it. If you want to find the middle of two numbers, what would you do? Take the average, right? Add them up and divide by, there's only two numbers. Add them up and divide by 2. So that's exactly what we're going to do here. Add them up and divide by 2. So for me, that would look like the midpoint would be 4 plus negative 1 divided by 2. 10 plus negative 4 divided by 2. Negative 4 plus 3 divided by 2. Uh-oh. Look at my formula. My formula says x1 plus x2, and I did x2 plus x1. Is that going to give you a different result? No, because adding is commutative. So our first one would be, that's 3 halves, 3 over 2. You could write 1.5 if you want to. That's 6 divided by 2 is 3. That's negative 1 divided by 2 is negative 1/2. All right, folks, there you go. Give it a whirl.